when the international community decided to ban methyl bromide, the choices of the pest controllers became very limited. Methyl bromide has been used for many years as the main material to fumigate food factories. With the absence of methyl bromide, it became very important to develop alternatives. And the opportunity arose to develop not only an alternative, but an environmentally friendly and healthy alternative. Dismate PE is basically a pheromone-based product. That product is used in solid dispensers in minute quantities to be hung around the factory to provide an atmosphere saturated with pheromone. In a nutshell, the male will not be able to find the female to mate. That happens through different mechanisms, but the net result is the male and the female don't have the opportunity to mate, and therefore the population will be reduced. As many of you know, in the food manufacturing environment, where the food processed are exposed to the atmosphere, and the factory is working almost certainly 7 days a week, 24 hours a day, the opportunity to spray or to fumigate during production is almost impossible. Therefore, the alternative, which is Dismate, can be used as a fumigant effectively, but during production time on exposed food. This opportunity has presented the pest controllers with wide-ranging opportunities to look at different situations where they could not look at it before. Naturally, female moth release its sex pheromone to attract the male when they are ready for mating. We utilize this behavior to control the moth in food factories. In effect, what we're doing is we're releasing large amount of pheromones in the atmosphere so that the male, upon their emergence from the pupae, they will be confused and they will be overwhelmed by the amount of pheromone, thinking that there are a lot of females around and all are ready for mating. That triggers him to go frantically flying, fanning his wings, exhausting his energy. Considering the male comes out of the pupae with a limited amount of calories, and he hasn't got any digestive system, therefore he's got to do what you've got. As a result, within less than an hour, the male will be exhausted, lying on the wall, unable to mate with any female, even if they came close to his proximity. The second mechanism in which the system works is by making the male addicted to a higher level of dosage of pheromones, so that their antennas are saturated and they're basically addicted to a high level of pheromones, so that when the female comes near them, it is not attractive anymore. They'll be more attracted to the dispensers rather than attracted to the female. The third mechanism is the trail masking mechanism, and that is, in addition to these two mechanisms, you have the female, when she's flying, she's releasing the pheromone behind her as a trail. By masking that trail with a lot of pheromones, the male will not be able to track her down. Through these three processes, we do control the moth mating behavior in the atmosphere. But that is not the whole story. To understand the system perfectly well, we need to be aware that there are two types of populations in the food factory. One is the resident population, and the other one is the passing population. Resident population is the population where they have their hibernation, they have their eggs, their larvae, their pupae in the fabric of the building or around the building, and they will be multiplying through this. The other population, considering it comes from the fact that the food factories have got always a food intake, raw material intake. These raw materials can be infested as well. By bringing in infestation continuously to the factories, that will undermine the system. This system does not control the passing population because you don't have time to do that. Because you might have a pupae, you might have eggs, you might have larvae. Pheromones do not act on these generation. It acts only on the adults. So we need to understand this before we raise our expectation too much. The second element need to be understood is the pheromones actually can be dispersed through the air. And the air movement in the factories are very complex thing. There are windows sometimes, there are some sources of heating, there are some sources of cooling, and the movement of air is very turbulent in all directions. That means we don't have a homogeneous air movement in the factory, and therefore the concentration of the pheromone might not be homogeneous as well. 3, inside machines and inside conveyors, the air movement is very slow, and most likely you have some debris and some food waste inside. What does that mean? It means the moth can find a nice microclimates inside the machines where they can develop a complete life cycle without needing to get out of it. Dismate cannot control that population. And therefore, to be able to control the population well, we have to do 3 things. Number 1, we control the infestation with the incoming material by insisting on the suppliers to provide us with as clean material as possible. Number 2, placing the dismate wherever we can in a particular format as it will be discussed in the literature. And 3, and most importantly, is to keep looking at these discrete hidden populations and to destroy them. Otherwise, if we don't look at these 3 elements or 3 sides of the triangle, the system won't work. In other words, in addition to the system, we have to have a very effective hygiene and cleaning system, in-depth hygiene and cleaning system, and 2, a very strong quality control on the incoming goods. As a responsible pest controller, we need to weigh the risk associated with the application of Dismate PE in comparison to the risk associated with the use of other insecticides. Where does this risk come from? There are 3 elements of risk which we'd like to address. 1 is the active ingredient itself, which is the pheromone, and 2, the dispenser. Number 1, the material. The material is natural pheromone released by insects, has got a very, very low toxicity, almost certainly considered as a non-toxic, used at a concentration of 1 milligram for every 250 cubic meters per every 24 hours. Considering the amount of food passes through any food facility in that period, in that space, one could extrapolate the amount of pheromone, even if deposited on the food, is going to be parts per billions. In other words, almost undetectable. So you would have an undetectable level of residue of a material which is not toxic in the first place. So that's what we're talking about. Number two, are there any tainting to the food? Well, A, the pheromone is odorless, and with the amount of in the air, it's no risk of tainting the food whatsoever. Now, the dispenser. The dispenser is a solid dispenser, and there's a potential that might fall into the flow of the food and cause a problem. Well, Dismate PE has got all the precaution needed to prevent that. The dispenser itself has been tagged with a metal detectable strap of metal, so that if that dispenser, for whatever reason, went into the food, it will be picked up by the metal detectors at the end of the process. Number two, the dispenser is attached to a plastic base using a metal detectable tag, and the whole structure is either nailed, screwed, or glued to the wall. So the whole complex comes in one piece, all of them metal detectable, whether in parts or totally, and be picked up at the very end of the process. This unique nature of Dismate makes it very attractive for high-value food and high-value brands. Dismate PE is not for everybody. So we have to choose our customer carefully, the customers who can really reap the benefits of this technology. Who are they? Number one, customers with a high-value brands, very well international brand names of chocolate, cereal, dried fruit, etc., will benefit from that, particularly to processes toward the end of the production line. Processes where going to have the product end up in a package and end up on the shelf in front of the customer in a very short time. In other words, people with high value brands nearer the end of the manufacturing supply line. Many suppliers and manufacturers in the up level of the production stream may not benefit from that, because the insect is, if it is a dead insect or a larvae in the food, it might not be visible to the final consumer and might not be so interested in dealing with it in such a way. So the main thing is to start with is with customers, as I said, high value brands closer to the shelf, as close as possible to the shelf. Number one. Number two, corporation with high environmental responsibility. Companies who are taking their environmental responsibility seriously. Dismate, the use of Dismate can save people the use of toxin materials affecting the ozone layer. And that's a very important factor. And thirdly, stopping the use of methyl bromide and replacing it with a product like this, reducing any potential risk of chemical residues in the food itself. So there is a consumer responsibility. So what are we talking about here? We're talking about how companies, A, they have a corporate responsibility toward their brands, they have a consumer responsibility toward their consumers, and they have an environmental responsibility toward the atmosphere. These people are the prime customers for this particular product. What do we expect from Dismate? Well, Dismate is not going to destroy the whole population overnight. It is not a toxic material which will poison the insects. No, it will not do that. What it does is to prevent mating. That means the living insect will remain living, but when they get to the level of mating, they will not be mating. Therefore, there is a gradual drop in population. To be able to measure that, you need to have a good monitoring system before you start the process, whereby you know what is the trend of the population, and when you apply it, you will see the drop. And the drop will be gradual, step by step. But you need to make sure there is a drop. And if that drop stops, that means there is a problem in the system which needs to be investigated. Number two, and that's something we could do, if we measure, if we monitor the amount of eggs being laid by females, you will find as well that the number of eggs are reduced. How do we measure that? Very simple. By allowing the female to lay eggs, putting it in an incubator, and wait for them until they hatch. You will notice that the hatching for eggs in these traps will be gradually. Are we going to end up to a zero level? No, we will not do that, because there will always be a new infestation coming in. But what we can do, we can reduce it up to 90–95%, providing we have a system in place, a hygiene system in place, and a good quality control of the raw material in place. What do you expect from us? Well, knowing this technology is new, and most of you are not familiar with it, we are not going to leave you alone with it. We're going to help you all the way from designing the trials and designing the site, the layout, the incorporation of the system, the incorporation of the hygiene system, and the monitoring throughout. If any questions, any problems arises during that application, we are available to support you. This system is not a single application. It's a round-the-year application. It's a total commitment from the pest controller, from the food manufacturer, from the hygiene officer, from everybody concerned, who are committed to deliver a factory free of moth. And for that end, we will support you.